Hello, so this is part 2 of having a look at this hybrid Yaqin VK-2100 stereo amplifier. If you haven't watched part 1, I recommend watching that first. If you have, let's go on. So first I just want to show a couple of features I've added to my software here. So the first feature is external attenuation factor. So this is for adding external attenuation to the analog discovery because it's limited at plus minus 25 volt peak to peak input. Beyond that it will start clipping. So measuring larger amplifiers, that becomes a problem really quickly. So here you can enter, basically you just click on the value down here in the corner and you can enter an attenuation factor. So I would probably add a dB as well. So you have a choice between attenuation factor or dB. So attenuation factor 2.1 basically means this is a 2-to-1 attenuation. So as in, if you have plus minus 10 volt coming in, then that would, after the attenuation, be plus minus 5 volt. Okay, so the second feature I've added is this little blue trace we see down here. So this is somewhat equivalent to, on the classic distortion analyzers, HP, etc. You usually have an error output or something that will show you the output from the measurement with the fundamental tone notched out. So what we look at here is basically everything except the fundamental tone. So it's going to be all our distortion and all our noise is going to be shown on this blue waveform here. So it's of course on a different scale because else we wouldn't be able to see much. So we can see we got plus minus 12.75 volt scale for the signal here, and the distortion is on a scale of plus minus 264 millivolt. So it's not 100% time aligned with the signal, so I'll try to see if I can fix that at some point, but still it gives a pretty good picture of what's going on here, where we have a very prominent second harmonic from this amplifier is definitely dominating the harmonic distortion. So we can see we got fundamental here and second harmonic is only 43 dB down, and it's very clear that this is the dominant second harmonic we're looking at here. Anyway, that was just a quick view. So let's get back to I want to see how much power we can get out of this amplifier into both 4 ohm load and 8 ohm load. Okay, so looking here at harmonic distortion versus power output, we can see we hit about 1% distortion, somewhere around 75 watt. So yeah, 75-80 watt and above, slightly above 85 watt, then it really starts clipping. So that looks okay. So let's try into 4 ohm. Into 4 ohm we can see we get about 110 watt before clipping sets in. So it's probably the power supply that's a little bit limited to how much it can actually deliver, but and keep in mind I'm only measuring one channel here, so in reality it will probably be a little bit less, but anyway, looks okay. Okay, so I've taken the top off the amplifier here, the cover. We have a look inside. So the cover was screwed down with a lot of screws. It's like 4 in the front here, 2 in each side and 6 in the back here. So I think that's because it gets pretty wobbly, see here, because normally on these heavy amplifiers the bottom plate will have some kind of pattern stamped into it to stiffen it, but they haven't done that here. It's just basically sheet metal they bend to shape. Anyway, first glance, it looks quite okay. Then we have one main board here with the two amplifier channels, tubes over here. It looks quite good. The heat sinks are a little bit strange shape. I'm not sure that's the most efficient way of making heat sinks. Usually it's the surface area that gives a better heat sink. And another thing I noticed is that all these are mounted all the way down. They're touching the bottom of the casing here, and there are no holes in the bottom, so that certainly ruins the efficiency of the cooling a lot, because, well, usually you will have cold air will rise up as it gets hotter. It will rise up, so that's not going to happen here. So it will probably make a lot of sense to just drill a number of holes under the heat sinks here, and I think it'll run a lot cooler. Oh, we have a fairly substantial transformer over here, so but that is needed if you need to deliver 2 times 100 watt or something like that. Probably a little bit less, 70-80 watt, 2 times 70-80 watt into 8 ohm load. And the tubes, I was not sure whether they were actually part of the circuit or not, but they are. So we have a 190 volt AC coming from the transformer here, and all these capacitors here are rated for 450 volt. Well, it's a little bit too high rated because it's only going to be about 250 volt here when this gets rectified. So 450 volt capacitors here is a little bit overkill, but anyway, they're definitely part of the circuit. So another thing I've noticed is the grounding here. So this does not look great. Don't know if you can see it. I'll try to see if I can zoom in a little bit. So basically these wires are ground and they're just soldered into a lock here that's screwed into the side of the case, and it just looks like a normal wood screw here. That looks a little bit fishy. Probably, and it's loose. It's not actually very tight in there. So it would be interesting to see if go back here. So it would be interesting to see if this ground connection is actually properly connected here. So let's try our meter here. Test. So if we take a point here on the front plate, hope you can see that. I'm just taking a screw hole here, and so there's no connection here. It doesn't look like it. Yeah. So do we have doesn't look like there's any connection over here. So yeah, that's not good. In case wire falls out here from the mains and shorts to the cabinet, then well, the fuse is probably not going to go, and you're going to have like a very dangerous situation. If you touch something on the front plate here, you're actually going to get shocked quite badly. Let's see if there's a connection between the transformer here and the front. Yeah. So I think this grounding lock here, maybe have a look at that. Maybe put a crimped lock in there and screw it in together with the transformer here. I think that would be better. Certainly looks a lot safer. So that's minor, not a small issue there. I'm just going to clean it up a little bit inside. It's quite dirty. So there's kind of some stickers on top of the capacitors. I guess there's perhaps a risk the top cover could touch the capacitor. And the capacitors, the two main capacitors here, says it's Elna capacitors. They're branded Kenwood, so I don't know if it's some leftover stock or whether they are real Elna or not, but kind of look okay. The main rectifier here seems a little bit strange to put it here. I guess that's gonna get pretty hot. I would expect probably going to have several amps going through this rectifier. It's probably a 10 amp rectifier, but it should really be on a heatsink. So don't know why they haven't mounted it on the heatsink over here. I'll try measure how hot it actually gets when we power on the amplifier. Besides that, so we have some extra fuses down here. So I guess that's for the plus minus DC for the output. There's another fuse over here. Not quite sure, but it's probably for the, because there's something that says AC 190 volt here, so that's probably for the supply to the tubes in case they short out. We have a couple of pots here, so probably a bias adjustment and DC offset adjustment. I would guess we could probably measure bias across one of these resistors here. See what it's like. So we have the same two pots over here. So it's kind of reasonably separated into two channels here. We have some relays, probably some delay switching on the output, prevent destroying speakers when you switch it on and off. But besides that, I mean, it looks reasonable. Probably need some fresh glue on here. Not sure if this has gotten really hot or not. There's a bit of a bump in this capacitor. I expect it's okay. So the board is single-sided, but they've done a nice thing where they actually put silk screen on top showing the traces on the bottom. That makes it a little bit easier. If it was faulty, we need to find out what's wrong with it. Oh well, it looks reasonable. Just a quick final look inside the amplifier here. So I've moved the grounding here from the screw over here to go together with the transformer, so it's screwed in one of the transformer screws here. So I got a locking washer on there as well, so it's definitely a lot better. I've cleaned off most of the dust, just very simple. So cleaning off dust from old boards, I usually just use a brush just to loosen all the dust on the boards, and then you just use some compressed air and it will all come off and it will look very nice. No need to use chemicals or anything like that. I decided not to start drilling holes under the heatsink. If it becomes a problem, I'll probably do it, but I just feel to do it right, you need to take everything out and get all the holes nicely aligned before I start drilling. So maybe some other time. Anyway, just quick test on the grounding here. If we do the same test I did before. Okay, so we try from the front here to the heatsink and then to the ground over here on the power connector. It's a good connection to everything. So yeah, it's the way it should be now. So I'll just close it up and maybe we can have a quick listen to what it sounds like.
Sail away, New England. I wound up in New York City.
So that's all you're gonna get of sound. Otherwise YouTube is probably going to complain. But overall, I'll say it sounds pretty good. It's got no problem with these speakers. Nice deep bass, good mid-range, but talking about sound and recording it for YouTube probably doesn't make much sense, to be honest. Anyway, thanks for watching, and I hope you have a nice day, and I'll see you next time. Bye bye.